Types of resistors. To regulate the current through an apparatus, there's a range of types of resistors available. There are four most common types. These are the carbon film resistors. You recognize them by this light grey color. We have metal film resistors. They're sort of bluish like. We have wire wound resistors, and if you look careful, you see really a wire going round and round. And finally, we have surface mount devices, here enlarged very much because they're very small. But how do you recognize which resistor is which, and especially what's the value? How do you find the resistance value? Because, of course, if you want to regulate the current, the resistor must have the correct resistance. And the resistance value is indicated differently on each type of resistor, and that's you have to recognize how. On a wire wound resistor, there's a written code like this one, 42R 5% 10W. Well, the 42R means 42 ohms of resistance. The R replaces the unit of measurement, but it also replaces decimal point. So 42R means the decimal point is behind the 42, so it's 42R. But for instance, if you have 4R2, it means 4.2 ohm. The R replaces the decimal point. But it can also, the letter can also be a prefix. We always use a capital, so that makes a bit of a change. So 15K5 is 15.5 kilo ohm, and 3M0, that's 3.0 mega ohm. The rest of the code, 5%, that's the tolerance. The resistance value can deviate by 5%. When producing it, it's not always possible to make it exactly 42. They aim for 42 ohms, but maybe it's a slight bit more or a tiny bit less. And this is how precise they're made. The smaller the tolerance, the more accurately they have been manufactured. And this means it can differ about 5%. And 10 watts means it can sustain a maximum power of 10 watts. And that's because these types of resistors are always called power resistors. They can handle much more power than the other types. So this one is for 10 watts. The other types can handle no more than about a quarter of a watt, and that's already much. First, the surface mount resistors. They're very small. And there's a code on them. Also a code, a written code, or 3 or 4 digits, or in other cases, it's 2 or 3 digits with a capital letter R. And here you see a few examples of them. They don't have mounting sticks, so no piece of metal sticking out, just a little bit of metal on the sides to which you can solder a wire. And they're about, 2-3 millimeters in size. Well, the code. First of all, have you more digits or more characters on it? It means it's more accurately produced, a more accurate resistor. And again, just like in the previous slide, the letter R replaces the decimal point. So here are some examples: 4R2, 4.2 ohm, 42R, 42 ohm, R42 means 0.42 ohms. And 420R, if you have one with 4 characters on them, is 420 ohms. If there are only digits on them, so we won't use prefixes like K or M here, in that case there are only numbers on them, then the last digits is the exponent of the power of 10. So here are some more examples. 422 doesn't mean 422, it's 42 times 10 to the second ohms. 424 is not 424, but it's 42 times 10 to the fourth ohms. So you have to add 4 zeros after the 42. And 4242 is one, of course, with 4 digits, so more accurately produced. And this one is 424 times 10 to the second ohm, so 42400 ohm. And the last one, well, you can read 4200, 420 times 10 to the 0 ohm. That's how you work with SMD resistors. Leaves carbon and metal film resistors. And they have quite a different way of putting the resistance value on it because they have a color code. Carbon film resistors have 4 colored bands around them. Metal film resistors have 5. Like, for instance, these. Well, these are not colored yet, but just to give the general expression of them, we have also given them names. We have them the A band, B band, D band, and T band on the carbon resistors. Carbon film resistors and metal film resistors have one more, and they're called A, B, C, D, and T. And this is the meaning of them. It's a mathematical expression. A, B, D, T bands means AB as figures times 10 to the power of D plus or minus a tolerance of T%. And, well, you might have guessed, in a metal film resistor, it's ABC times 10 to the power of D plus or minus T% of tolerance. But what do these colors mean? They have a color code, so each color stands for a figure. For the A, B, C, and D bands, it's black for 0, brown for 1, red for 2, etc. 4 is yellow, 5 is green, 7 is violet, 8 is grey, 9 is white. And then we have 2 that look a bit different because -1 is gold and -2 is silver. Now, -1 and -2 you will only find in the D band, and 8 and 9 you will not find in the D band, just because it's not practical to make such high values of resistors. The T has slightly different color coding, although it's the same colors, but with different meanings. So a gray T band, it means a tolerance of 0.05%. A green T band means a tolerance of 0.5%, while a gold band means a tolerance of 5%. Let's do some examples to show you how you can work with these. Let's take this one, for instance. Violet, white, yellow, and finishing off with a green T band, recognized by the space between them. Violet, that's a 7. White is a 9. This is a carbon film resistor, so the third band means the exponent of the power of 10. So 7, 9, 79. There's no dots in between. Times 10 to the power of 4. With a tolerance of plus or minus 0.5%. This example for a metal film resistor. How do we find that? Let's look downstairs again on the schedule of colors. We have blue 6, yellow 4, black 0. Then we go to the exponent. That's times 10 to the power of 5. And the tolerance band, we have a tolerance plus or minus red 2%. 640 times 10 to the power of 5 plus or minus 2%. This one, can you already guess? Yellow, red, black, silver. Yeah, 42 times 10 to the power of 0. Yeah, we can also do that. Plus or minus 10%. And the last one, last example, one more. Let's just do one more. This one. Found it? Green, white, orange, silver, gold. That is, yeah, I think you already know it. It's 593 times 10 to the power of minus 2. Yeah, because we have no decimal points. We have to create the decimal point for the low figures by using negative powers of 10. And this one has a tolerance of 0.5%. So now you know for every resistor, well, these 4 most common types, how you can find the resistance value for them.